Yes. Second are perpendicular. This is 1/5 and -5. And then this third are perpendicular. Yes. Next page. These are parallel. Yes. These are perpendicular. And these are perpendicular. These are parallel, perpendicular, and perpendicular.
Yes.
Parallel, perpendicular. Anyone get stuck on that one?
No.
Good. And then parallel.
Yes.
And then parallel,
Yes.
perpendicular,
Yes.
parallel.
Yes.
Good job.
Yeah, like the two is messed up, so like.
So today we're going to do a little bit more with parallel and perpendicular lines. There's going to be three.
Is this all you do in life anymore? This on my phone. I don't like that.
Yours is going to look a little different than mine wording wise and I think spacing wise, but it says the same thing. The font is just different. Because I think I was supposed to print off this version, but I had extras of those. It's whatever though. It says the same thing. So what we're going to do today is just reiterate what we learned last class and then do different examples from what we did before. After what we do today, this will help you guys do the Khan Academy that's due on Friday. So let's fill in these definitions first. These are going to really be like our rules. So the definition is going to be graphically, and then algebraically we'll do our rules. So the definitions of parallel lines are two lines that never intersect. Algebraically, we found that we know two lines are parallel if they have the same slope. But different y-intercepts. I wrote that way too. If we wanted to write a shortened version, and this will be nice when you move on to geometry, this will be something you remember like, oh, parallel lines, I did that. The symbol for parallel lines looks like a vertical equals, or two ones, two L's, whatever. They should be even though. I don't know if that made it better. So instead of writing out parallel, if you wanted to do the symbol, that would work. Then for perpendicular lines, the definition for those are intersecting lines that cross at a 90-degree angle. And what we found about perpendicular lines algebraically, we know two lines are perpendicular if their slopes are negative reciprocals.
Doesn't have to be negative.
It has to be. It can't be like 1/2 and 2 because 1 isn't negative. So then those would just be intersecting lines, not perpendicular lines. This is like the definition of negative reciprocals, but I don't remember exactly what I said. So I'm going to go to the next page so we can see what that was. A fraction flipped and the sign is switched. So that's the definition of negative reciprocal. A fraction flipped and the signs are switched. So I'm going to rewrite that on the other one so it's a little bit bigger. Fraction flipped and the signs are switched. So let's do some examples of negative reciprocals. You guys can say these out loud. What would the negative reciprocal of 3 over 4 be?
Or it could be negative 4.
Negative 4 over 3. What about for 2?
Negative 1/2.
Negative 1/2. What about negative 7 over 8?
Positive 8 over 7.
Positive 8 over 7. What about positive 1?
Negative 1.
Negative 1. And then what about 0?
Undefined.
Undefined.
Negative undefined.
So you could think about it like that, but undefined is undefined no matter what. And if that part doesn't really make sense why those are negative reciprocals, we know this is 0 over 1. If we were to take that and flip it and make it negative, this would be undefined. Whether it was positive, negative, doesn't matter. So we have to know that 0 and undefined are negative reciprocals, therefore making those perpendicular lines. Okay. This next part is determining whether lines are parallel, perpendicular, or neither, based on the slopes. Some of these we will need to find the slope, and then later we'll be given equations where we look at the slopes or have to convert it and then find the slope and compare. You guys have 6 boxes here. My other 2 are on the other page. So we're going to start at number 1. We're going to find the slope of both of these. Just so you remember how to do that, I'm going to write off to the side our slope formula. y2 minus y1 all over x2 minus x1. You guys have like answer boxes right here. You just squeeze that in somewhere over there. And I would say take this one at a time. So find the slope of AB and then CD or vice versa. If you need to label them, do that. So for AB, we would have 6 minus 3 over 2 minus negative 2. Or, what would the slope be?
3 over 4.
3 over 4. And then I'm going to go ahead and find our slope of CD. And do the same thing. I'm going to go ahead and label these. This would be 3 minus 0 over 3 minus a negative 1.
3/4.
This would also be 3/4.
Parallel.
So these would be parallel. So at the bottom, I'm going to draw the parallel. Oh, I didn't put the perpendicular symbol. I would draw the parallel symbol, or you can write out parallel. So you find what the slopes are, and then you compare them. Before we do another one, I'm going to go back up real fast. The symbol for perpendicular lines is an upside down T. I didn't make these symbols, I'm just drawing them. I could find that out later if you remind me. I don't know the answer to that.
I'm sad.
Do we have any questions on how we found that those two are parallel? We're going to do 2. I don't remember which ones I want. I'm sorry, there's 8 total. You guys, I think there's 2 more on the back. 3 more? Yeah, okay. So we'll do one more of these. Alright, we'll have to put also. 2, 3, or 4. Pick one of those and we'll do that. Or 2? Okay. Same.
I was just gonna ask.
Okay, go ahead.
My pencils.
Alright, for number 2, let's do the same thing. Find the slopes of these points. So that would be 4 minus 2 over 5 minus 0. What would our slope be? 2/5. And then we can find our slope of CD. We have 3 minus 8 over 3 minus 1. Negative 5 over 2. So these would be perpendicular. You can put the symbol or you can write out perpendicular. If you were to get 2 slopes that are like completely different, so if I get like 1/2 and 1/3, those would be neither. They're not the same, they're not negative reciprocals. Just put neither. Because the answers to these are either they're parallel, they're perpendicular, or they're neither. Neither would be they intersect, but they're not parallel or perpendicular. A neither case would also be if you get like -2 and 2. They both have 2, but one's negative, so they can't be perpendicular because they're not flipped and they're not exactly the same. Or like if I had 1/2 and 2. They're flipped, but one isn't negative, so they can't be perpendicular. We're going to do 2 more of these, and I'll let you try some. We're going to do 5 and there was another one that I wanted to do. We'll do 5 first. Alright, so for number 5, I'm going to go ahead and label them. If you don't need to label them, then that's fine. So that would be 7 minus -2 over 0 minus 0. What would that give us? Which is 9 over 0 is undefined. So make sure that even though you get this as a number, that you know that this is undefined.
And 0 over 3, you guys.
You're so far ahead of me. Give me 1 second, and that I'm sure that is the answer. So CD, we have -5 minus -5 over 6 minus 3. This would give us 0 over 3. Which, what did you say is? 0. So these would be perpendicular. If you didn't put that these were undefined and they were 0, if you just had 9 over 0 and you had 0 over 3, you would probably think these are a neither case. That's why you have to know that 9 over 0 would be undefined, 0 over 3 would be 0, and then you have a perpendicular case. Another thing with these, and I believe this is something I mentioned like when we were first doing this slope. Here we have the same x's, which means they would cancel out in our denominator and be undefined. And in our second one, we have the same y's, and they would cancel out in our numerator and be 0. What if I got 2 that were both undefined? Then they'd be parallel. Same thing with 0. If they were both a slope of 0, then they would still be parallel. Do we want to do one more together, or do we think we got the gist of this enough to start these problems? So I'm going to give you about 15 minutes. It may not take you that long to go through and do the remaining problems. But stop when you get to 9, or for the equations part, we're going to start those together. Let me know if you have any questions.
No, you don't. You can wait for the teacher to go over it with you.
All right, let's go over these. The number 3 should have been neither, however you say that.
No. You just put no.
Yeah.
No.
Because these should have been 2 different slopes. Okay.
Me.
Guys, I can't hear this question. Say that again. Number 4 should have been perpendicular with the slopes of -1/3 and 3. Questions on those 2? Number 6 was parallel. They both should have had a slope of negative 1/2. Your number 6 may be on the front. And then 7 and 8, I think, for you are on the back. Yeah.
Okay, now, for the 5, right, the 5 and negative 10, why did we put the negative 10 to the negative 1?
Divide these both by 5. Oh, you mean now here is negative and here. It doesn't matter where the negative goes.
It was on the picture, but that's fine. No.
Yeah, that's fine.
He's such a weird.
Go back to your table. Number 7 was parallel. They should have both been undefined slopes. I think that was the one I wanted to go over, but those aren't. 8 was perpendicular. You should have had a slope of negative 1 and 1. Did we have questions on any of those, Graham?
Number 6, the negative 7.
So this part, the negative where we put the negative doesn't matter. Alright, we're going to do some of the equation ones. Okay, we'll still do them. So for the equations, they're kind of like the ones we did this morning or earlier in the papers you have. Look at your slopes, and if they're already in slope-intercept form, you can see if they're parallel, perpendicular, or neither. So for number 9, will these be parallel, perpendicular, or neither? Parallel. They have the same slope, but they have different y-intercepts. What do you say? One more time. I feel like I should know what that means. No, I know like the show or whatever.
The trivia show.
For number 10, would these be parallel, perpendicular, or neither? Perpendicular, because we have a flipped slope and one of them is negative. For number 11, would these be parallel, perpendicular, or neither? Neither. They're almost the same, except one is positive, one is negative. So they can't be perpendicular because one's not flipped. But because one is negative, they can't be parallel either. We're going to do 2 more, and then I'll let you do the remaining. For number 12, can we say whether these are parallel, perpendicular, or neither right now?
Because they're not just
Correct. They are not in slope-intercept form, so we have to change both of them to be in slope-intercept form first. Doesn't matter which one you do first. On the left, we will need to subtract x on both sides. We have 6y equals, I'm going to switch these two, so it's negative x plus 30. And then divide everything by 6. This would become negative 1 over 6x plus 5. The second equation is almost in slope-intercept form, but we need to divide everything by 3. So we get y equals 6x minus 2. Now, looking at both equations, are these parallel, perpendicular, or neither? These are perpendicular because one is flipped and one is negative.
Wow.
The last one we're going to do together is number 16. With 16, do you need to remember your Poiseuille's? For y equals, which type of slope would that give you? It would be a horizontal line. It would not be an undefined slope.
Zero.
It'd be 0. For your x equals, you have what type of slope? Undefined. So would these be parallel, perpendicular, or neither? Perpendicular. Another way you could see if these are parallel, perpendicular, or neither is if you draw them. So I'm going to quickly draw like an x and y axis. My y equals 6 would be somewhere up here. My x equals -1 would be somewhere over here. And I can see that they cross and make that perfect T. Or L. Either one. Mine's a little crooked, but it should make that. Do the remaining 3 in the next 5 to 10 minutes, and then we'll go over those, and I'll explain what you're doing for the remainder of class. For 13, 14, and 15. 13 should have been perpendicular. After you solved the first one, you should have got a slope of +5. 14 was parallel. Both of them should have a slope of 3. And then 15 was perpendicular. Do we have questions on those 3? For the remainder of class, here are the things you could be working on. Some of you had this page, some of you I had to give this page. You can practice this more by doing this. So these are all determining if they're parallel, perpendicular, or neither based on the equation. So you can go through this, answer these, to practice this. You have one delta math on parallel and perpendicular lines that is due, I think the due date says next week, but I think I messed up the due date. Anyway, you have one delta math, and then you have one Khan Academy that is based on what we did today, that is due on Friday. So you can be working on any of those 3 things, or if you finish one, move on to the next. You finish 2, move on to the next. You finish all 3, let me know. You do have time to possibly finish all 3, but that depends on how much you are working. Does anyone have any questions on what we're doing for the rest of class?
It's good.